So, hello and welcome everyone. I'm still solving some technical issues and I'm done. So, hello to my first Q&A for Rust experts. I'm Florian Gilcher. I'm working as one of the managing directors of Ferrous Systems, and I'm also part of the Rust project, though I have to say today is my personal stream, so all my opinions are either my opinions of myself or of the company. And I would like to talk today about Rust in the industry. That's a super broad subject, and that's why I would like you to, through the course of the whole stream, start asking questions in the chat. What's your opinion on this? What's your opinion of that? Do you have any kind of insight? I spent the last 7 years both in the Rust project and in my companies talking to people about Rust, or how it's useful, how it could be adopted, how they adopt it, how they use it, why they're not using it, and all of these kind of things. So I have a lot of knowledge, and the way to pull this knowledge out is, to ask me. And to start things off, I came up with a couple of subjects. And the first ones, I would actually like to take the chance to go through the Rust survey a little and present my reading of it, and a little bit of what I find interesting about it, what I find teasing, and what my conclusions are. That would be the first part of it, and also in that talk about the state of Rust in the industry a little bit more in general. I would also, as a suggestion, talk a little bit about where companies are using Rust, why they have picked it at that location, and also a little bit about what my conclusions are, how you can improve the adoption of Rust in the industry, you as yourself on the position you are. But if you ask any kind of questions in that regard, so that I know a little bit more of what your situation is or what your specific question is, that will help me. Also, we already got a question: is embedded Rust ready for programming a giant crab Mac? If not, what's missing? That's actually a good question. Thank you. And I will add that. Oh, it's a mecha. Sorry. The difference between mechs and mechas is known to me. I would like to start talking about the survey. Let's see if my setup works here. There we go. That came out this weekend. This is definitely not a planned coincidence, but a happy one, that I have such a nice and good subject to talk about right off the bat. So for those that don't know, the Rust survey is conducted every year and takes a broad view of everything that's happening in the Rust community. And it's running for the fourth time now, I think. Yes, 2015 was the first one. And it's a huge source of information. I would like to mention one thing about these kinds of surveys. When we started the survey, it was unusual that such surveys were conducted. There was not a lot of data about programming languages, and that's still the case. It's getting better though. Especially, I would like to highlight how the Go project also runs an awesome survey. And the just released the 2019 edition also, I think, over the weekend. I still have to read through that. It's great, because the big problem that you have with programming languages, and that also brings us to the subject of adoption, is there's actually not much research, and there's not much data, like really reliable data, on how a programming language is adopted and how are they and how does the process work. You can find a couple of research papers, but really just a small number. And that already points us to the problem that if I talk about adoption in the industry, this is my very personal view, Also for the reason that it is pretty hard to actually find reliable other sources around that. So I'm sorry if it ends up a little bit hand wavy at some places, and definitely needs to be seen as a personal opinion. The first thing that I would like to highlight is survey audience. Pretty often it's that people say, yeah, if you're a programmer, you should learn English and you should consume English material. And that is true. A lot of the main documentation is in English, and it's definitely helpful. Still, especially as a third language English speaker myself, it has to be seen that it's still better for people, or easier to people, to work in their mother tongue. And it also shows in the survey audience, actually 30% of all surveys were filled out in non-English, especially a lot of Chinese. We have a huge Chinese community, and we have a huge German community as well. Although you also have to see, I know a lot of German people that would fill out the survey in English, so that doesn't map exactly to the community sizes. And this year's blog post doesn't include the community sizes because the focus was different. And so the first thing I would like to highlight is the looking back at Rust 2018 part, because Rust 2018 had a number of important goals, like the edition 2018. And we had asked people to rate the improvement of key aspects of the language. When I say we here, we as the project, this was project work. And the interesting thing here is the improvements here are clearly on the some improvement, a lot of improvement side. The I don't know answer is always like the kind of bailout answer where you can't say much, like that person probably hasn't given the subject much thought. And we pretty rarely, and you can see that in all curves, we pretty rarely have responses that say something got worse. And especially the focus of the 2018 edition and the work through the last year was improvement of async programming and async I/O with the async await feature, and the response has actually been good. There has been some improvement or a lot of improvement, and a lot of improvement probably comes from the fact that we actually introduced a whole new syntax that completely changed how async programming works in Rust, especially on a syntactical level, and so this improvement is not surprising. Compile times, the classic. At least things are towards the improvement side. The Rust compiler is still slow. And GUI development, it seems like not a lot of people are doing GUI development, but it seems like this whole thing has stalled. It's also interesting, has your IDE experience improved in the last year? We've put a huge highlight on making sure that tools work better, improving RLS. Also, might have seen there's an RC open to actually adopt Rust Analyzer as into the project, and there we also see a lot of improvement. Coming back to the subject, Rust in the industry. The good feedback that I hear out of the industry, especially out of slower moving industries, for example, industries like industrial engineering that actually have to ship products that are working, that have to work and be supported for years, is usually if you talk to those people, you talk to research people or people that are in special working groups for evaluating new technologies. These working groups exist and exist more and more. Companies are starting to figure out that the technology world is changing and they have to change with it. And even if they are slow movers, and that is something that I often see in discussion, like in this industry, no one will ever adopt Rust because they are slow movers and they're so slow movers. This is actually not true. These companies nowadays usually have research departments, and these research departments work on the timescales of years and decades. And one of the feedbacks I got from them was, from one of those departments, was we looked at Rust like 2 years ago, in 2017, and got a list of things out of it, which we found not up to our standards. We found it interesting, but there were certain things lacking. So what they did was they wrote down all of these things and came back 2 years later and had checked, essentially asked exactly the same questions. Like everything we found lacking 2 years ago, is that better this year? So the whole process is more of a, is that going in our direction? It's not, the question that companies are asking is not, does that fit our bill now? What they're asking is it on the way towards our direction? And the moment you hit a certain threshold, interest gets higher. Suddenly they're like, can we help you? Can we improve that? Then we're starting, at some point, companies start adoption processes. And adoption is not, we're now using Rust. An adoption is, we're now looking at, do we want to use Rust in the future? So we're starting to use it in small projects. We'll start to use it in larger projects. We're going to document. If you're operating on the scale of a larger company, this is how, if you've got a proper adoption process in your company established, this is how they work. So adoption, when I'm talking about adoption, it's not, does this company use Rust? It's, does this company move towards using Rust? And that's the moment people start adopting the language. Starting with a small project, maybe they scuttled a small project later, but at some point they figure out, was the experience with the language good? What were the problems that we had? Did these problems improve? So these graphs are incredibly important. And it's incredibly important that the got worse part stays low. And this is actually a good argument to make if you are in your company and you're trying to argue for Rust, is like, for the past 4 years, we have figured out that the got worse part is always very small. So we're moving towards better fitting the needs of people and the needs of companies. And these conversations are much more worthwhile than figuring out like, oh, there's 20 unsound issues in the compiler. Yes, it's a piece of software. It has bugs. These are not the conversations that companies are interested in. They're interested in a far more pragmatic, discussion of, is this going to improve our software? They're not looking for something bug-free. They're looking for something that improves their software. And in the end, that boils down to money, but that's how it works. So I wouldn't go as abstract as talking about it just saves you money. That doesn't work, because that completely takes out what Rust or what the thing even is, what it promises. But these kind of more large, these kinds of big picture things are far, far more important. Same goes on for library support, stable language features, and crates. An interesting part is that Rust documentation is a little bit on the left side. It has not seen that much of a focus, but I come to how that is important in a second. Conferences and community, that's probably a question we won't ask next year, because, or we may ask it next year, but in a different way, as all conferences that I currently know of have been cancelled. I don't know about RustConf. That's actually the one that I know about. And but what's interesting here is I find two things very, very interesting coming from the community side of the Rust community and project. I was quite happy because I'm always against centralized community efforts. I'm happy to have centralized support, and that's how the community rolls. You can always ask. There's a certain place where you can ask experts about how they would do things, and you can give help. That's actually a thing. If you're running a meetup or something like that, please feel free to always send an email to community@rustlang.org. And but one thing that I found is, for example, the common blocker that people mention to participating is that they have social anxiety and accessibility. One of the common reasons mentioned was that some sources are hard to read for people with dyslexia. These are things to cover and to make easier, and these are things that call for tight and small knit groups. If anxiety issues are your specific kinds of issues, it's probably more helpful if you have a small group of people that you constantly interact with, instead of going on Discord, going on a large chat with 1,000 people and someone randomly answering. That is actually mentioned here. Smaller groups of helping people. Social anxiety is making it hard to talk in Discord, for example. So this is something, a small learners group in your company, a small learners group in your city, even if there's a Rust meetup already. One of the reasons why the Ruby community, for example, in Berlin got so successful, I'm wearing a Ruby shirt today, is that they did exactly that. They formed small learners groups, 5 to 6 people, that were boosting themselves up. And if you're talking about adoption, form a small learners group within your company, or form a small learners group together with people from the company next door, and then talk about your experiences in making Rust a thing in your work life, if you're currently still a hobbyist. I would like to skip a couple of these things. One thing that I find interesting and found very, very surprising is, what industries do you work in? So really, really industry-based question. And number 3 is embedded devices. And there's a number of others where I'm not sure if people have selected both. So for example, Internet of Things, or somewhere down there's robotics and healthcare and aerospace, which are probably those people wouldn't check embedded devices, and strictly speaking, some of the things they're working on are not embedded devices, but they're pretty close. So Rust on small devices is a surprisingly popular thing that is not often written about and not often talked about at conferences. So that's another effect to look towards. Public perception of industry adoption is not necessarily the reality. There's a lot of companies that are silent about what they're using, what tech stack they're using, except when before they actually come out with, hey, this is what we're doing. There's industries where it's just culturally not relevant if it's Rust or C and C++, so people don't talk about, we're doing that in Rust. So there's always a certain bias in all of these things. What do we talk about? Because for example, there's only ever 10, 12, 20 talk slots on RustConf. This selection, even if we unbias it during selection, always has a natural bias, because we can't run the full gamut of what's happening. We always have to select what's most interesting to the audience, and probably popular or teasing, not necessarily popular, teasing, and where you have speakers that actually want to speak about this. So these kinds of surveys are really, really important, because here people have the anonymous way of saying, I'm actually working in embedded devices and I'm doing Rust. And suddenly they're number 3. So this is a huge, huge thing that we need to talk about. Okay. And the other thing here, why not use Rust? I want to end my run through the survey here, but why not use Rust? The most popular reason is still my company does not use Rust. Shouldn't be forgotten, also a little bit of selection bias. The people that talk most about their work on the internet and are spending their free time talking about Rust on Twitter or something like that are not a good representation of the general workforce, and this is what we're talking about when we're talking in the industry. There are tons of programmers who just go to work day by day, and their programming language skills are just their way of making their living. And this is definitely very, very valid and has to be accounted for. And for those people, if your company is not using Rust, you can't have your bills paid by it. So it's not a useful tool for them. They're not into mind teasers, essentially. And those people need to be approached very differently. It also has to be, there's a social effect when we're talking about adoption. If you are introducing a new technology into a company, you will end up in a situation where some people feel their livelihood threatened. And that's especially this audience that does only use their skills for that. So taking fear is actually like telling them, hey, you can still use your C++ debugging skills or things like that. Taking fear and spinning a positive story on like, this is going to improve your skill level over the next years. And this is actually a chance for you, or this is actually a positive development for everyone, especially the people doing the work. It's very, very important because otherwise you end up in situations where people emotionally fight hard against this kind of change, even if they may be open to your technical arguments. So that's a pretty interesting conversation to have. Okay, I would like to stop it here and work on the first round of questions. There was another one by Stefano Probst. I work on MIPS Linux UC libc systems. That is a tier 3 target. We already submitted some PRs to Rust libc. Do you know any teams or working groups I can get into to coordinate the MIPS UC libc efforts? So if you don't know, so this is more of a project question, but I'm going to answer that. If you don't know any team or working group to address when it comes to these kinds of questions, there's always two paths. If you absolutely don't know who to address, you can talk to community@rustlang.org. We will always forward you to somewhere. We get tons of PRs every day. So figuring out if there's actually a cluster of people interested in maintaining and getting a target higher is surprisingly hard, because sometimes you could just have a surprisingly big flurry of PRs from a very interested individual, and that may die off. So that's always hard to judge. We're on the internet, we don't see the people. So being explicit about we're interested in moving this target up the tiers, and that also means a certain maintenance level. That's really, really important. So also talking about, and that gets me back to my main subject, there is practical interest in this target. For example, there's industry users that need better support and all of these kind of things. Also, talking to the compiler team is probably a good move, because they are more into into the details of what they expect when moving the support level of a certain target up the tiers. You don't need to be in a working group in the Rust project to improve a certain aspect. You can also just say, we are a group of people, we're going to open up a GitHub organization somewhere, and we are going to improve the support for MIPS, Linux libc systems. And we're going to take care of that, we're going to post pull requests. At some point, it just makes sense to at least have one person joining a working group for representation. And that would probably be compiler infra or something like that. If something like that is also something we usually call a working group or a task force. So just a very, very specific subject. We don't claim to be, but the Rust project itself is pretty open about that. Okay, I think it's an interesting question to talk a little bit about the mechanics here. Nikolai Vasquez asked if embedded Rust is ready for programming a giant crab mecha. If not, so what's missing? I think the giant crab mecha is missing. That's the first problem. So what's missing in that direction? Mainly work. The language is ready for that. And that brings me back to there's always some gaps. And engineers are usually have a huge focus on the technical details. We always see the flaws. There's still a problem with the compiler, there's still a problem with that, there's still a problem with this. If I take the idea of building a giant crab mecha by 2027 or something like that, if the number of issues that still exist with the Rust language is manageable of size, that does not block you from using it. What's missing pretty often is support for specific kind of hardware. And that's a practical issue. Someone has to write it. Someone has to write the drivers. Someone has to bring a board up. Someone has, and this is work that we have definitely done in certain settings. We get a board that some vendor wants to use, but it doesn't run Rust yet, but they would like to use Rust. So we take the board and write all the drivers, make it working. The so-called board bring up. And this already exists and people are doing that. The second part that's missing is definitely a low usage of Rust in safety critical environments, if I consider such a thing safety critical. And that's kind of a circular problem. Low adoption means that people, like the problem in safety critical environments is that your technology needs a track record, that it's reliable. So without the track record, people don't rely on it, and taking the whole thing about, ignoring the whole thing about qualification and verification and all these kind of things, just for a second. Still, it's trust problem. So no one has used it in that environment before. That's not quite true. There are people that have used Rust in low safety critical environments, but you need to have previous usage and good experience, and then you have more usage and more experience. And so it's kind of a ladder process. So you need people who actually want to go on such an endeavor and are convinced that this is a useful technology for such an endeavor, and then be ready to move up, start moving up that ladder. It's And that is something where older technologies, especially in those environments, older technologies have a huge advantage just because they are understood. People know they have flaws, but they know what the flaws are and they can manage the flaws. Adopting Rust is, okay, it eliminates a number of flaws, but we don't know what the flaws are that this technology has, and we don't know what the flaws are, and we don't know the quality on how it fixes the flaws that it says it fixes. That's a practical experience problem. It's not in the abstract. So the goal to more adoption in the giant crab mecha industry for Rust is building more giant crab mechas in Rust, and maybe starting with small ones. So that applies to all these environments, to everything where a huge amount of trust and reliability is needed. Trust and reliability is built through usage and track record, which is also why we have started the Sealed Rust project so early. One of the thinking about, let's start writing about Sealed Rust and let's start thinking about Sealed Rust. Sealed Rust being our endeavor to bring Rust to the safety critical space is the language is ready for that. It's just the whole adoption process is a path where you need to start small and you need to start going bigger and bigger and bigger. Yeah. So, okay, that's my part about the giant mech building. I like that the question was actually in the abstract, because if it's a plane or a robot or something, the social process behind that, it's not a social process. It's actually a quite reasonable process. If there are huge damages or lives at stake, don't start with something with something huge. Start with something small and build experience and see if things actually do what they tell you that they do. Okay. The next question, I'm going to pull that into my question document here. 1 second. We are a small consultancy that would love to find customers. That's the question from David Bonnet. We are a small consultancy that would love to find customers that want to introduce them to Rust. If in your experience, what's the best way to start you may want to try Rust in a company? So the problem is that consultancies have the tendency to sell you things and in the end not maintain them. This is inherent in the model. I've been running consultancies for 10 years. As a consultancy, it is not your interest to hook yourself to a company, sell them something, and then constantly maintain it. So there needs to be an amount of internal interest within the company. There's two ways of doing this. I've seen the case where there's a long-running business relationship with a customer that is technology curious anyways. And you're like, hey, would you like to try out a new technology? We've got experience here. We think that would fit your use case well. The biggest issue there is making sure that making a very, very clear plan for the moment our business relationship doesn't exist anymore. How are you going to deal with that piece of software? You have no Rust programmers. How are you going to deal with that? The biggest importance there is we're going to make sure that you're going to have Rust programs. And I do have, my main experience with that comes from doing Elasticsearch consulting before, when it was really, really a new thing. And what we did there was basically boosting teams up. Teams that were interested in Elasticsearch, and we were like, okay, we're going to help you, and we're going to make that better, and make this team better. And my learning out of that, my experience with that is, and that's a little bit of a tough sell depending on where you are. I don't believe in 40-hour consulting anymore. If you want a 40-hour week, which is essentially you get a programmer on a certain subject for 40 hours a week. Because the tendency will be that all the hard tasks in that field of endeavor will land with that experienced person. And that might make sense if you have absolutely no interest in building experience in that kind of thing. There are tons of things that fall under that category. So you can always say, this search function, we're not going to use it, we're always going to build it with external people that actually understand search, which I think is a reasonable take. On the scope of a programming language, I don't think that works. There I'm more into a gradual slope down, saying, hey, let's start using Rust. Find a couple of people within your company that are interested in doing that. We're going to start working with that. We're going to start working with you for the whole week, for like 3 to 4 weeks, really small amount. And then we're going to slowly pull our people out. Why? Because people need to have the experience of how do I deal with a language if the expert isn't around. Suddenly they need to solve their own problems. Suddenly they need to solve the problems themselves. And that's a point where at some point you will end up pulling yourself out. That's the helping people with adopting Rust route. So you have an interested company that would like to adopt Rust internally, and then you're teaching them. You're building basically their seed team. The second path is, does the programming language really matter as much as people say? Because of that effect that I told you about, there's often the effect that an external company builds something, and once they're done and the contract is finished, internally, no one really wants to deal with that piece of software anymore. At some point, they scrap it, and that's fine. I think that effect it's a reasonable choice on the client side. And in that case, the question is, do we really want to discuss the programming language we're using? Do we want to make this a main subject, or do we want to make this kind of relationship the main subject? So talking to clients about what are you actually using that software for? What's your expectation of its reliability? We've got a tool here how we can actually establish your reliability. The reliability guarantees that you want. So having more of these kinds of discussions. An interesting effect that I've seen is talking less to... The problem that you often have in a tech consultancy, and that's pretty local to tech consultancies in my experience, is that if you... It's actually not. I hear that experience also from marketing people. And so if you're talking to your peers on the other side, so you're talking to the programmers on the other side, you will always get pushback, or they will always focus on these kind of subjects. What programming language is it written in? Is this a programming language that I know? Is it something, all of these kind of things. In a well-run company, talking to the business people more about what's your reliability needs, what's your maintenance needs, all of these kind of things. You're moving out of the technology a little, which allows you to do what we always claim. That's like using the right tool for the job. And that's the experience that you have. You know what the right tool for the job is. And if you are a good external company, you will not sell Rust to a company just for selling Rust, but you're going to sell it because you know that all these things that the client needs, you are experienced in doing that in Rust and being able to ship it in a way where they actually don't notice what the programming language is. The only thing they need to do is install Rust up on their CI server if they do so. So that's my very, very high level answer to that. It's still a tough sell, but more and more companies are intrinsically getting interested in Rust. It's also a cultural difference. US companies, for example, are far more used to looking way out in the distance and checking what's going to happen, and just having a little bit of play money around to try out things. While I know that, for example, German companies have the saying of, oh, if that catches on, we'll follow fast. They're not early adopters. And I don't think this works, because that means, coming back to experience, that means the moment Rust catches on becomes, it has already become a viable option. And then you suddenly have no experience. All your competitors have far more experience than you do, and this pretty often happens in the German tech environment. That we are following the trends of 2 to 3 years ago, and not in a good way. I know companies are doing that in a good way, because they have consciously decided that they're going to follow the trends like with 2 years of lag, and have a very, very good internal process of actually taking out the nuggets in those 2 years. So they have internal experiments. They're not adopting it, but they have internal experiments so that they know, okay, if we decide to adopt it 2 years later, we already have people that have played around with that. Okay. Motor. Next up. Recently on the Ferrous blog, a proof of concept was posted for async on embedded. This has not yet resulted in new embedded async rates. What do you feel is needed to help this along? So we are still working on this. What is needed? First of all, it needs to be stabilized. That was our proof of concept to drive the compiler patch that we have provided to actually make futures run on async. So removing thread local storage and making the compiler more clever around that. So that was basically finishing work that we already knew about. I think what is missing is a little bit of the notion of understanding on what this could be used for. So more experimentation. I think more experimentation is needed in what the async story on embedded is, and also how it flows into the main async story. I'm also not sure if this should result in new crates like right off the bat. I usually put a time frame of around 6 months at least between the implementation of a concept on even halfway well-formed usage. So I'm not fully sure how to answer that, because that's basically, I need my crystal ball. But yeah, it's an early proof of concept using our compiler patches. We have seen a number of pull requests to the repository, making it work on different kinds of systems. One thing that I would be interested in seeing is things like a couple of real-time operating systems and embedded operating systems, whatever you may put under that umbrella, do already have asynchronous abstractions and asynchronous APIs. I would be interested in how easy it is to write an async await shim layer on top of these. I think that would be the thing that, as a mind tease, currently interests me most. The other thing that, again, if there's common interest in that, in async on embedded, getting in touch and forming a group that throws these ideas around, I think would be helpful, because a lot of these things, this in the open source world, there's often the tendency of avoiding forming groups, and everyone comes up with abstractions themselves, builds them, and then you end up with a library, and then someone else builds another library, and in the end you have 20, 30, 40 web frameworks, and none of them does cookies correctly. That's a bit glib, but I've definitely seen that happening in some environments. And so forming a group that says, we are interested in looking what async await, what the potential of async await on embedded is, and would like to experiment as a group, maybe just set up a Zoom call somewhere and just throw ideas around. I think that helps. And also people taking the charge and in a way of making that their focus subject. Async await on embedded is currently our research subject, our one research subject that we have. And we only ever have one, and that's just for reasons of overload of bandwidth and the size of the company. And having someone who's like, okay, this is something that I would like to drive forward in the next half a year, and I'm going to at least figure out like who's all interested, what are the ideas of all the people. This is a task for a single person for half a year exclusively, I would even say. Like something you can do in the evening, but something you can, but something that you should put focus on. So I think that's probably what's missing. A champion that is interested to gather all the people that are interested in dealing with that subject, and maybe this talking to, for example, implementers of certain kinds of craze, for example, bindings to the aforementioned operating systems. I hope that answers your question. Anything else? There's questions. I am going to wait for 30 seconds. I know the stream lags a little. Let's go to check if Twitter has. Okay, if there's no more questions, I've actually got a closing topic, and then we're going to actually hit the end time. Also, just feel free if you want to add a question, just type it in the chat. So I would like to talk about the state of Rust in the industry in general and the location of Rust projects within organizations where I usually see them. So first of all, I think the state of Rust in the industry is good, and a lot of adoption that we're seeing is in a lot of high value places. So for example, if you have a look at Amazon Firecracker, the micro VM that runs a lot of small services, especially I think it's currently behind Amazon Lambda. These are very, very good locations to be in as a programming language. My experience from Ruby was sometimes things are very hidden. I used to do a lot of Ruby before. For example, my usual joke was any company that says they don't do Ruby does actually run Ruby. Because my old company does a lot of infrastructure work, and the moment you have a look at the data center of someone, you're like, okay, so what is that dashboard implemented in? Oh, it's Rails. Oh, and that dashboard is Rails as well. Oh, okay, so you actually do Ruby. Yes, we have Ruby services deployed. The moment you're in that location, you're basically done. Then your language is adopted in a fashion where people rely on it on important critical systems and get their use out of it. And they're not going to go and build it out again. There will be people adopting Rust and then at some point going away from it and even coming back. We've already seen that. We've already had large deployments where something was implemented in Rust, then it was re-implemented in something else, but then some other part in the company got re-implemented in Rust because of the experiences that they had. Companies very well understand that their first project with a new technology will probably not be a good one. And that's fine. That's a normal process, and no other programming language has any kind of advantage over Rust in that. Even your first Go project will be, your second will be better, and your third will be better. And that's no flaw of Go at all. And the location where we see those projects are really, really desirable. Infrastructure work, package routers, Linkerd, things that the fabric of your stuff. That's where you see Rust. That's really, really interesting. That's also why we see a pretty interesting shape in the Rust web frameworks. Rust web frameworks are not very good at actually rendering websites, but they're actually quite good at building APIs, at building reliable small APIs. Or, for example, embedding them into a host program or something like that. So even if things are unfinished, we're seeing a lot of desirable use. So the state and the location of projects is pretty important and pretty interesting. But that also means, again, coming back to my point from before, these projects are often working in the hiding, and pretty often they're implemented within the organization itself. That's sometimes tough for people that would like to work as external programmers. Pretty often those kinds of projects are done with internal task forces, which I think makes sense for any kind of project adoption, the technology adoption, because the problem with technology adoption is twofold. First of all, you need to trust the technology. Second, and if you don't trust the technology, you need to trust the people that implement it to actually tell you if something worked well or not. So that the feedback, like let's try something in Rust. You need to trust the person to give you good feedback. So if you're doing a technology adoption as an external person to a company, you need to make sure that you have a really, really high trust level, and also to be extremely honest and say, okay, this didn't actually work out for that and that reason. Got another question from David Bonnet. What would you like to see more in Rust in 2021? I'm actually quite happy with the language as it is. I do see an amount of work to be done for async await, more documentation, also more understanding. I think one of the biggest problems, especially in async programming and async await programming, is a lack of understanding of what it actually means. And you can see that in the kind of questions that people ask. Things like, but if I'm awaiting for everything, is my code really asynchronous? Yes, it is, because there's another task running asynchronously to it. The question of, is the future the unit of concurrency? is the task, the unit of concurrency. And now we end up in a problem that if we're talking about units of concurrency, there's not a broad understanding of what that actually means. And this is, so we need more base level education of what this feature is actually there for, and when I should actually not use it, because async await doesn't solve each and every of your problems. And this is actually something I would like to see better documentation and learning stories and more translated material. That's basically my main wish. Jake Murdish is asking, I guess I'm going to run over a little. Jake Murdish is asking a question, I hope I pronounced that name right. I work on a driver that needs a daunting amount of interop with existing C++ code across internal libraries, both calling into and calling from. How are places handling adding Rust in such an environment? Lots and lots of generation and making sure that your C++ code follows one strategy and your Rust code follows one strategy. The biggest problem in interop is if every of those components handles itself a little bit differently. And that's not really a Rust or a C++ problem. That's mainly a software architecture problem. And for that, I would check up with the people who did the integration into Firefox, because that's basically the largest place where such a thing happens. And the biggest problem that I see at interfacing layers, and that's not really for C and C++ and Rust, is really, can I make reasonable assumptions on how the other side works? And if I cannot, how can I make that work? And one of the things that a lot of people are doing is writing a C++ shim that they exactly understand how it works. C and C++ shim. Pretty often they're using, they're going from they're implementing a C API on top of their C++ API because it's easier to interface with C. And then they're writing one glue layer, and then they're binding to the glue layer. That's pretty often the strategy that people take. But without looking at the exact code, I can't give a lot of general advice there. But that's definitely a strategy I've seen quite often. Actually spending time on the C and C++ side to make sure that you actually got a good interface layer and then binding to that. The last question we got is, should Rust be used to implement other programming language like like the Artichoke project is trying to implement the Ruby language VM in Rust, or should Rust be used as a primary language only? So the good old joke from the Ruby world is there's a Ruby built in everything, still is very much alive and kicking. And I wasn't surprised that the first thing someone tries to implement in Rust is in a large scale is Ruby. Yes, Rust is pretty much a language to build other languages in and to build things on top. I think that's the core of being a systems programming language. And you see that in a lot of questions where people are like, for example, can Rust be like Erlang? I was like, yeah, you could build an Erlang VM in it and then you could run Erlang on it. VMs have their use and a different mode of operation than what Rust does that runs on bare metal hardware. And it's actually a good language to implement these things in. I think Rust is a good primary language. It also has its flaws in the sense that Rust is a very, very detailed language and wants to talk about memory much. And that's good. It might not be what you need all the time. If you want to have a system that only does message passing, use Erlang. And if you want to have a safer implementation of the Erlang VM, well, write one. It's a ton of work. So that's the main problem. But yes, Rust is very much intended to be a base language for implementing other languages in. The main problem that you will face is, again, one of experience. How do you implement a programming language in Rust? Which parsers do you use? What are the techniques you use? And all of these kind of things. There's a lot more things to look at if you're using C and C++, you can have a look at other programming language implementations. You can look at C, Python, you can look at C, Ruby, and all of these kind of things. For Rust, there's always some transfer needed. Or, well, there's already a couple of programming language implementations around that you can look at, but just the amount of previous work that you can look at. Like that. Yeah, it's just smaller. Okay. Well, that concludes my Q&A. Thanks for the questions, they were really good ones. And well, we're going to repeat that like weekly, someone else from Ferrous answering questions. If anyone got a topic that they would like us to talk about, you can also just suggest topics, send us an email, just write to office@ferroussystems.com. Also talking about this kind of support that I was talking, external experience support. We have this project called rustexperts.com, where we give you kind of expert level Q&A. The difference to Stack Overflow being you can ask us basically any question, we do the research for you. It goes beyond what public Q&A gives you, and we also do small scale code review and all these kind of things. Happy to have you here.